Go ahead, Rohan.
Yeah.
Okay, go ahead.
Can you guys see the screen?
It says it started. Yeah, we can see it now. Present this.
Okay, yeah. So my topic was targeted cancer treatment using nano drug delivery, and my name is Rohan, and I go to the Downingtown STEM Academy. So with my topic, targeted nanoparticulate drug delivery for cancer treatment, I wanted to solve the issue of cancer and its widespread cases amongst the world and the deaths that it causes, as well as come up with a solution other than the harmful treatments such as chemotherapy, radiation therapy, and others. So some of the questions I had were, how can I increase the efficacy with these nanoparticulate drug deliveries while limiting the systemic toxicity, which essentially just means that how can I increase the effect it has on killing cancer cells while limiting the adverse effects it has on other parts of the body. And I also took into consideration what might be the associated challenges in doing this, and I had to weigh the benefits and limitations with considering whether these new nanoparticulate drug delivery systems are better than current treatments. So my objectives in doing this were to investigate possible nanoparticulate drug delivery systems for targeted nanotreatment and identify challenges and opportunities for optimizing a targeted treatment. So my literary review, I had to take into consideration the efficacy of current nanoparticulate-based drug delivery systems. So currently, we use organic. There's research on organic drug delivery systems and inorganic, and those are the main uses. So while these directly deliver drugs to cancer cells and minimize side effects on healthy tissues, there's a lot of issues with drug resistance and microenvironmental difficulties, which causes a decrease in the efficacy. So I did some research and I found something called smart nanoparticulate drug delivery systems. So these smart nanoparticles carry and release anti-cancer drugs, similar to chemotherapeutic drugs, but then they release these drugs based on biological stimuli such as pH changes, enzymes, temperature changes, optics, and magnetism. And some of the nanocarriers that were most promising in doing this were carbon nanotubes, black phosphorus, and MOF nanoparticles because they have the most unique properties. And with carbon nanotubes specifically, they have more capability in carrying more drugs. And with black phosphorus and MOF nanoparticles, they're more unique and they have different properties than others. And with these smart nanoparticles, another great thing is that once we do more research and we come up with new findings, we can pair this with AI and ML with uh, computer programming. So another thing I found that was really important was hybrid nanoparticles. So hybrid nanoparticles, basically what they do is combine the advantages of different nanoparticles by combining their materials. So this includes organic nanoparticles and inorganic nanoparticles that come together. As some of these examples include lipid polymer hybrids, organic inorganic hybrids, and cell membrane coated nanoparticles, which just means that the nanoparticles are coated with the cell type. So with the hybrid nanoparticles, they can have a severe positive effect with combination therapy and others to target various factors which improve drug resistance, such as efflux transporters, which basically pushes out any drugs or things that are trying to kill that cell, defective apoptotic machineries, which basically opposes the cell's apoptosis machineries, which means that it won't die and that the cancer cells will keep growing, as well as hypoxia and more. So my methodology. As you can see, I conducted research from credible papers around the world using sources such as the National Institute of Health, Science Direct, and more. So with my research, I had to compare the benefits and limitations of various nanoparticulate drug delivery systems, such as organic nanoparticles, inorganic nanoparticles, the smart nanoparticles, and the hybrid nanoparticles. So with comparing the benefits and limitations, I had to focus on drug resistance as a crucial variable, as well as the ability to target the cancer cells. And in the end, I narrowed it down to a few nanoparticulate-based drug delivery systems. So in my results, the most promising nanoparticulate-based drug delivery systems for the treatment of cancer were smart nanoparticles and hybrid nanoparticles. Smart nanoparticles and hybrid nanoparticles are very similar, but smart nanoparticles are nanoparticles which are basically infused with anti-cancer drugs, like I said. And what makes them unique is that it has the ability to detect biological cues, unlike regular nanoparticles or hybrid nanoparticles. The most promising nanocarriers for these were black phosphorus and MOFs. On the other hand, there's hybrid nanoparticles, which use combined nanomaterials, and the most promising were carbon nanotubes and others. In conclusion, my question was, how can we treat cancer with increased efficacy and less adverse or unwanted reactions? So in the end, I found that hybrid and smart nanoparticles serve as the most promising methods of targeted cancer treatment with the most efficacy. With more research in the future, I think these two drug delivery systems can be very crucial in treating cancer, instead of these harsh treatments such as chemotherapy and radiation therapy. So my contribution: while there are many other researchers conducting crucial research to a purely efficient treatment to cancer, my research outlines new and more efficient methods of nanoparticulate-based drug delivery systems, which can be built upon and be more developed. One of the limitations is that these new nanoparticulate systems, such as smart nanoparticles, are very new. So there wasn't much in-depth information, but there was indeed a lot of information about these. Thank you so much. And I would like to give a special thank you to Dr. Christina and Professor Virgil. So with Professor Virgil, I remember through like the Zoom meetings and everything, we had so many questions, and Professor Virgil was very patient in answering them, and she was very sincere in answering them. And with guiding us through the research paper, I think she split the parts of the research paper up so that it was more understandable to us as high schoolers. And with Dr. Christina, she really split the field of nanoparticles, and I liked how she focused a lot on biomedicine, because that was what we were focusing on in our topics. And also with the structure of like the classes and sessions, Dr. Christina she started off with a more broader take on nanoparticles, and then she kind of zoned in on specific topics and our topics, and she gave more concern to our topics as a whole. Thank you.
Amazing, great job. You want to, yeah, one second, let me stop Sai's video. Yes, Dr. Christina, a question for Rohan.
Thank you. Thank you for this. I have a little bit different question for you. So imagine right now, you can go and do some research on some of these particles you mentioned to improve their properties, to improve their functions, to improve the whole complex, the way we assemble it now and we synthesize it now. Which one would you go for?
So out of the three, the carbon nanotubes, the black phosphorus, and MOS, right? I think I would do the carbon nanotubes, just because like that had the most research currently, and I saw that there were new things such as wrapping the encapsulated drugs around the carbon nanotubes to increase their properties. So I think there's a lot of like areas that we could edit it and change it up to increase the efficacy of the cancer treatment.
Yeah, I agree with you. Given the choice, I would go for the carbon nanotubes as well. Most are interesting, but most have more limitations there.
Yeah.
Yeah. Okay, thank you.
Great job, Rohan. Yeah, keep your video on. I just have a few things. So, how do you intend on furthering this research? What steps are you taking? Because we don't want you to stop here, do we?
Like with continuing research.
Yes, and your
So I think I'm gonna, with all the help that Gifted Gabber has given me with like these resources and how to construct a research paper and things like that. I think I'm gonna use it to like try to do things, try to do a research paper on my own and get more opportunities that way, and maybe even start something to aid like teens in doing research,
yes.
because I think that could like help a lot with like my interest in research for the future. And yeah.
Yeah. So for people on the call and who are presenting today, you will be invited to be interns to help the new students. So Rohan, you need to apply and get in, because not only do you have access to Dr. Christina, you will be helping high school students, and it's like a valid employment with Gifted Gapper. So your activity with the research paper, you mentioned Dr. Christina's name, right? Research done under Dr. Christina Lilova, assistant professor or research professor of ASU. But the internship, you can put it as a research intern with Gifted Gapper. And I have employment agencies that call us to find out and everything. So we have a very proper tracking system where not only are you going to learn how to lead and mentor others, you're also going to be abreast with what is going on, because they are part of the Nano program. Okay, so
Okay, thank you.
I urge you to apply for the internship so that we can pair you with students. Okay, so
Yep.
great job, Rohan. Amazing.
Thank you.